Objective number 2. Construct confidence interval for the slope. The formula to find the confidence interval is that point estimate plus margin of error. We know that B1 is the slope for the sample. So the slope for the sample is the point estimate plus minus the margin of error. The margin of error we calculate by t critical value times SB. And SB is the standard error. We will find SB later. So first of all, we will compute the residual standard deviation. The notation is SE equal square root of sum y minus y hat square divided by n minus 2. So we look in the formula, we see that y is the y value in the data in the table, and y hat is the estimate. In order to find the equation of the sample, the regression line for the sample, we know that y hat equal b naught plus b1x. b naught is the intercept and b1 is the slope. We can use the Excel command. We need to enter the x value and the y value first, and after that we use the command for the b naught is equal to intercept, and then we follow the command in the Excel to see what they want us to input. And to find B1, that is the slope, then equal slope. And after that, you put both of them into the equation y hat equal b naught plus b1x. We have another way to find the regression line using Excel. And you do that using the add trend line. You make the scatter plot and then you right click on one of the points. So we need to review the chapter we learned before in order to review the regression line. So let's assume that we have the regression line already. And now we want to compute the residual standard deviation for the table below. The table below represents for the number of calories and the number of grams of fat per 100 grams of product for a sample of 18 candy products. So we have one candy, and one candy gives fat and calories. So this is for 1. We have 18 products, so we have 18 pairs. They give us in the x and the y. So we want to compute the residual standard deviation SE. First of all, we look in the formula. We already have y. We do not have the y hat value. The y is the actual value and the y hat is the estimate value. We need to use the regression line to do it. Now we look in the solution. What do we do first is, first of all, we need to input the x value. We need to input the y value. We use the Excel to find y hat. Now, how do we find the 428.640.817 number? So what do is we plug in the x value right here. We plug in 12.75. So we will get 428.640.817. Similarly, we do the second one. We will plug in the number for the x is 25.99. We plug in this x value. So we will get 503.305693. For the third one, you will plug 21.13 into the x value. Okay, so we have two y value. This y value is the actual, and this y value is the estimate. We find the residual. The formula of the residual is y minus y hat. To get this number 7.359183, what do we do is we will take the y minus y hat. And then for example, this one, okay? So we will take 4, 5, 6, the y minus the y hat, and so on. So after we got the residual, we need to square the residual. The residual is y minus y hat square. After we square it, we will add them up. We will add all of these numbers up, the pink number, and we will get 3,398.6787. So after we get that number, we go back to the formula. The formula to find SE, the residual standard deviation. Let's copy the formula down. SE equal square root of the sum of y minus y hat square divided by n minus 2. So we already calculate the sum of y minus y hat square, which is 398.6787, and we already square that number. So this is the sum of y minus y hat square. And you just divide by n minus 2. We have 18 pairs, 18 products. So 18 minus 2. 18 minus 2 is 16. You will divide that number by 16, the 3,000 number by 16, and then take the square root. So you will get the answer is 14.57457.